Okay, ladies and gents, we are on to the kind of the final concept of this particular unit, and that's the idea of quadratic optimization. We can solve quadratics, we can factor quadratics, we can complete the square, we can use the quadratic formula. We know how to find the vertex, we know how to find the axis of symmetry, we know what a function is, we can do all of that. Now it comes to how can we apply this knowledge? What can we actually do with it? And one of the most useful features of quadratics is that they are really good at showing like the path of something that's thrown, the way an object goes. We can also use it to describe like how much money a company makes. So what we're going to do today is something called quadratic optimization. So whenever we optimize something, optimization optimization means we're finding the minimum or the maximum value. That's what the whole game is. So depending on the context or what the function is, we're looking for either the max or the min. So if it's a quadratic that has its a is less than 0, then when we optimize it, we're looking to find the maximum value. So we're looking to find basically the y value of the vertex. Now, this is generally like if you throw a ball, it follows a parabolic arc. That's very, very common. So that would be something that we would be looking at. Similarly, if we had a function that was a happy parabola, or rather, we'd be looking for the minimum value. That could be something like tax rates or whatever else. So what I'm going to do, rather than go through this whole process of explaining it to you, I figure we just do a problem. I say we, but I'm going to do the problem. You're going to watch the video. You're going to take some notes, and you're going to go, "Oh, that's so profound!" Like, and plus, God, Stoltz looks good. Like, I'm just so happy I get to see him, even though he's not here. And this is for you. All right. I have a calculator that I borrowed from a student. But people are getting suspicious, so I decided to throw it from a cliff into the ocean. As one does. The height of the calculator in meters as a function of time and seconds can be described as that. Okay, so most often, any type of story problem or thing, it's helpful to to if you can just diagram it, it makes your life a lot easier. So we've got a cliff, we have the ocean, we have a very handsome Stoltz at the top of the cliff, and he throws the calculator into the water like that. Now, what we know from this is we have the question is, if I am 1.8 meters tall, how tall was the cliff I was standing on? So we know right here, 1.8. I guess we're assuming I'm throwing from the top of my head, so like that. Got 1.8 meters. Now, we know that the original function is negative 10, negative 1/10, t squared plus 3t plus 10. Okay, so that is my original function that we have there. Well, if we were to translate this onto a coordinate plane, then the place where this took off from is going to be my y-axis, right? So this is my y-intercept. And ordinarily, it's when time is 0. What would that be? However, with this added thing, because I'm looking for the height of the cliff, I'm actually looking for the question is getting at us trying to figure out what this height is. That's what we're after. So all we have to do is to find the height of the cliff, it's going to be 10 minus 1.8. So it should be 8.2. Wow. Yikes. 8.2, because that's the path of it. So that's our first thing. Next up, how long was the calculator in the air? Okay. So again, our y-axis is our height. Our x-axis is time. This is confirmed because we're using t as our function, and I think it's also clearly stated, as a function of time in seconds can be done as that. So the length of time it's in the air starts right here, and it's when it lands in the water. So I need to know what this value is. Well, hopefully we recognize that's a zero. That's one of the zeros of this function. So in order to solve this, we just need to find the zero of the function. Now, again, we have options. We can use the quadratic formula. We can try to factor this thing. Looking at it with negative 1/10, I don't think I really want to factor it. We could complete the square. Similar things. So let's just plug and chug through the quadratic formula, okay? So I want to know when h of t is equal to 0. So if I plug and chug this through the quadratic formula, that would be negative b plus or minus the square root of b squared minus 4ac all over 2a's, okay? So my b value is 3, so negative 3 plus or minus the square root of 3 squared minus 4 times negative 1/10 times 10. Oh, very clever, Stoltz. And this is 2 times negative 1/10. Okay. Simplifying this down, I would end up with negative 3 plus or minus the square root of 9 minus, well, negative 1/10 of 10 is negative 1, and times negative 4, so this is plus 4, and all of this is over 1/10, so negative 2/10. Trying to simplify this as much as I possibly can, I get negative 3 plus or minus the square root of 13, and all of this is going to be times 10 over negative 2, and I can further simplify that, so I can get rid of my negatives, so I would have 30 plus or minus 10 square roots of 13 all over 2. Now we just got to evaluate what that is. So to do that, I'm going to use my calculator because I am somewhat lazy. All right, what was my values? Okay. So I've got 30 plus 10 square roots of 13, and I'm going to divide all of that by 2. And when I do that, of course, my calculator is going to give me that value. I want a decimal answer, so I got to put a decimal in there. So it looks like it's going to take it approximately 33 seconds before it splashes down. So how long was in the air? We would say approximately 33 seconds. Next, we want to know when the highest point the calculator reached and when that happened. When we say highest point, we got to think vertex. It's just a matter of finding the vertex. So, again, options. If you complete the square, you have the vertex. This is in standard form or general form right now, so I'm not gonna complete the square. I am just going to use the formula for the axis of symmetry. So the axis of symmetry is always negative b over 2a. So substituting that in, I have negative 3 over 2 times negative 1/10. So this would happen at negative 3 times 10 all over negative 2. 3 times 10 is 30, divided by 2 is 15. So it's going to happen after 15 seconds. Okay? So after 15 seconds, we will be at this maximum point. And then, but we're after, what was the highest point the calculator reached and when did it occur? Well, this is my when. This is the time. To find the highest point, I'm just going to take that equation, negative 1/10, 15 squared minus 3 times 15 plus 10. Did I get that formula right? Oy. Yep. So again, I honestly think that this is a calculator thing. It doesn't have to be though, because we can do that if I can find it. So that'd be negative 1/10 of 225 minus 45 plus 10. So this would be negative 22.5 minus 35. That feels dirty. That doesn't look like that's going to work. And then I would end up with a, why is that not right? Negative 57.5. That doesn't make sense. What did we do wrong? I know what I did wrong. This was supposed to be a plus. That's plus 45. So this is plus 55. I can erase that rather than, we got it. Plus 55. 22.5 from 55 would be 2.5, and so it would be 32.5 meters. So the highest point was 32.5. That occurred 15 seconds after the flight. Doesn't make sense an actual thing. I don't know if you could throw something and have it stay in the air unless it floated like a paper airplane for 15 seconds, but we're going to pretend that that's true. Okay. Again, all we're doing is we're taking the skills that we've learned and now we're applying it in context. And I think if you just play around with this, you will find that this is super doable. Okay, hope you have a good day. Later.